Section 2.3 exercises. Problem 1. We are given 2 points and asked to find the slope of the line that would pass through them. To do this, slope, which is designated by the letter m, is the amount of increase or decrease in the y values divided by the amount of increase or decrease in the x values. If we visually look at the 2 points, the y values undergo a change from -2 to 5, which is an increase of 7, and the x values undergo a change from 4 to -1, that is a decrease of 5, so the slope is -7/5. If instead you wish to use the formula and label the 2 points as your first and second ordered pair, then we take the change in the y values, 5 minus -2, divided by the change in the x values, -1 minus 4, and we arrive at the same value of -7/5. The slope being negative means that the line, when graphed, would decrease as you move from left to right on the graph. Problem 2. We wish to find the point slope form of the equation of a line that passes through 1 point, -2 to -5, and it has a slope of 6. To do this, we write the point slope form. The functional value minus the y-coordinate of the point is equal to the slope times the variable x minus the x-coordinate of the point that the line passes through. This then is direct substitution since we are given all the information. So we write functional value y minus the y-coordinate, which is -5, careful to use parentheses there, is equal to the slope, given to be 6, times x, variable x, minus the x-coordinate, which is 2. And there is our equation in point slope form. If we now wish to solve the equation for y, we first will do the arithmetic. Subtracting -5 means to add 5, rewriting the slope, and times x minus 2. Now we distribute the slope of 6 through the parentheses, getting y plus 5 equals 6x minus 12. And then finally, subtracting 5 from both sides gives us y equals 6x minus 17. And this is the slope-intercept form, where the slope is given here by the coefficient of x, which is 6, and this number here, -17, is where the line, when graphed, would cross the vertical axis. Problem 3. We're now given 2 points that are on our linear function and asked to find the equation of the line in point slope form, and then, as before, solve that equation for y. This is similar to problem 2 and problem 1 put together. First, we'll calculate the slope of the line, and we need to get the change in the y divided by the change in the x. So if we compute this, we'll have -6 minus 1, -6 minus -1, divided by the corresponding change in x, -1 minus -2. Careful with the arithmetic here. Double negative in the numerator makes plus, and then in the denominator, another double negative makes positive, and so we arrive at -5 over 1, or slope of -5. Now, using the point slope form, choosing either point we wish, we can then write the point slope equation of the line. So let's choose our first point here, -2 and -1. So the function y minus the y-coordinate, -1, is equal to the slope that we just calculated, -5, times variable x minus the x-coordinate, which is -2. And since we wish to solve this equation for y, we'll have to push through and simplify this result. So y plus 1 is equal to -5 times x plus 2. And then, as before, we'll distribute the -5 through the parentheses, giving us -5x minus 10. And then we'll simply subtract 1 from both sides, giving us our final answer in slope-intercept form, negative 5x minus 11. Problem 4. Graph the linear function y equals 3/5 x plus 1. This function is written in y equals mx plus b form, where our m represents the amount of change in the y values divided by the amount of change in the x values, and that's given here to be the coefficient of x 3/5. In order to use that slope to graph the line, we also must have a point on the line, and we do. The b value of 1 means that that is the point where the line crosses the y-axis, so that's the point 0, 1. Translating this to the coordinate system, we locate the point 0, 1, and from that point, we move upwards 3, since the change in y is positive, 1, 2, 3, and then to the right 5, since the change in x is also positive, and that gives us the point 5, 4, and then we draw that line that passes through those 2 points. Problem 5. Graph y equals 3. Okay. If we wish, we could write y equals 3 to be y equals 3 plus 0 times x. And this way you can see that for any x value, to get the corresponding y value, we would multiply that value of x by 0, which would always be 0, and then add it to 3. So for any x value, the y value is always 3. This means that any value of x on the horizontal axis would have a corresponding y-coordinate 3 units above. So 3 units above is right here. And for any x value, let's label a few on the coordinate system. A few points, some randomly chosen x's, but all the y values have the same value of 3. And that makes the graph a horizontal line. And also note that the slope is 0 for any horizontal line. That's important to know. Problem number 6. Graph x equals negative 3. Okay. Using the same trick as above, we can rewrite x equals negative 3 to be negative 3 plus 0y. So for any y value, x is always negative 3. So on the vertical axis, no matter what value is chosen to be the y, the x-coordinate is always 3 units to the left at negative 3. So we'll locate a few samples. Here is negative 3, so we would have negative 3, 0, and we'd have negative 3, 2, and we'd have negative 3, 5, and we'd have many more points below it that all have the same x value for different y values. This makes the graph a vertical line. And just to note here that vertical lines have no slope. In a way, you can think of it to be infinitely steep, since it cannot be steeper than a vertical line. Problem number 7. We're given a linear function in a different form. This is called the general form. And we're asked to find the slope of the line and the y-intercept of the line. Well, if you want the slope and the y-intercept, I would suggest rewriting that function in slope-intercept form. So we will take the 6y, we will leave it on that side. We will move the 12 to the other side and the 3x to the other side. since we wish to isolate the y value by itself. So 6y is equal to positive 12 minus 3x. And then we can divide all terms by 6. 6y divided by 6, 12 over 6, and 3x over 6. And then that will simplify to y by itself, giving us 12 divided by 6 is 2, minus 1/2 times x. We wish to know the slope and the y-intercept. The slope is the coefficient of x, which is over here with the minus sign included. That's negative 1/2. And the y-intercept is the b value, which is the constant term, or the number all by itself without an x, and that will be the 2 here. Noting that it is a coordinate and should be listed as such, since that is a point the line passes through on the y-axis. So slope, negative 1/2, y-intercept 0, 2. Let's do problem number 8. We have another equation in general form, but we're asked to graph this in a different way. Find the x and y intercepts. So putting this in y equals mx plus b form is not the best way since we will not know the x intercept. I would suggest writing the equation down by taking the constant term over to the right side. Now, to find the x intercept, the y value is always 0. So finding the x-intercept means that you're on the x-axis, so the y value is always 0. Substituting 0 in here for y will give us 3x is equal to 6, or in other words, x is 2. Writing that as an ordered pair is 2, 0. So we can locate that on the graph right here as the x-intercept. Now to find the y-intercept, the x value is always 0 since you're on the vertical axis, which makes the left and right amount away from the y-axis always 0. That's why x is always 0. So we take our equation and substitute 0 in here for x, and that disappears, giving us negative 2y is equal to 6. Dividing both sides by negative 2 gives us y equals negative 3. So that is the ordered pair 0, negative 3. Transferring that to the coordinate system, right there, we can now draw the line that goes through those 2 points, and it would be something like that, right there. And notice the line slanting upward as we move across the graph from left to right indicates that it would have a positive slope, even though we don't know what it is. Problem number 9, application problem. We are given the function, let's call it y, and this will be the temperature, the average global temperature in degrees Fahrenheit, and our variable, we can name it x, and this will be the CO2 concentration measured in parts per million. So now that we have our variable and function defined, we are given 2 points. So this is the x, or the CO2 concentration, and this is the y, or the global temperature. And we can label that as our first ordered pair, and this one as our second ordered pair. And as before, we'll compute the slope using the slope formula. So we'll take the change in the y, 57.64 minus 57.04 is an increase of 0.6. So we'll have 0.6. And then 354 subtracted from the first x value, 317, gives us 37. And 0.6 divided by 37 is decimal 0.16. Note that the slope, which is the change in the function divided by the change in the variable, indicates that the average global temperature is changing in a positive way, which means it's increasing, by 0.016 degrees Fahrenheit per part per million of CO2 concentration. Use the function to project the average global temperature when the atmospheric concentration of carbon dioxide is 600 parts per million. So this is a value of x. And to do that, we need to finish the first part and write our equation of the line. So we'll use the point slope form. Either point here chosen will give the same result. So let's use the first ordered pair here and write y minus the y coordinate, 57.04, is equal to the slope that we calculated from above, 0.016, times the variable x minus the x value of 317. Okay. Now, since we're asked to project the y value where we know the x value, let's not simplify this, but instead immediately substitute x is 600 right in here, and then we will simplify. So y minus 57.04 is equal to 0.016 times x. X is 600 minus 317. And simple things first, do the subtraction inside the parentheses there. Y minus 57.04 is equal to 0.016 times 283. Now we'll multiply 0.016 times 283 and have 4.53. And then finally add 57.04 to both sides, and we will have our projected average global temperature. And adding the two together gives us 61.57, and that is the temperature in degrees Fahrenheit. And this concludes section 2.3 exercises.